Picture this, a vast ocean of stars, swirling like golden embers in the endless night. At its heart, a brilliant glow pulses like a cosmic lighthouse, the Galactic Bulge, the mysterious core of our Milky Way. What ancient secrets lie hidden in this dense stellar jungle? How did this glowing heart of our galaxy come to be? Tonight, let your mind drift among these celestial wonders as we unravel the enigma of the Galactic Bulge. Somewhere in that crowded stellar metropolis, stars older than our planet dance in slow motion around an invisible monster, a sleeping giant whose gravity shapes everything around it. From Earth, we see only a hazy glow in the constellation Sagittarius, but behind that veil of dust lies a realm of extreme forces and forgotten histories. Could this glowing core hold clues to our galaxy's violent birth? What strange worlds might orbit those ancient suns? As you settle in, imagine floating weightless at the edge of this cosmic whirlpool, watching as millions of stars perform their eternal ballet just for you. Where does your mind wander when you gaze upon this celestial mystery? Let the gentle pull of these questions carry you deeper into the story of our galaxy's beating heart. Now, let's step closer to this cosmic marvel. The Galactic Bulge isn't just a distant glow, it's the vibrant, pulsing heart of our Milky Way. Imagine a city of stars, packed so tightly together that their combined light creates a golden haze visible even from our small corner of the galaxy. This dense core stretches across thousands of light years, a swirling mix of ancient suns, interstellar dust, and forces we're only beginning to understand. From Earth, it appears as a soft, luminous patch near the constellation Sagittarius, but don't let its gentle glow fool you. Behind that curtain of cosmic dust lies a realm of staggering scale and energy, where stars orbit at incredible speeds and gravity weaves its invisible threads through everything. Picture standing on a hilltop, gazing at that faint golden smudge in the night sky, and realizing you're looking at the crowded center of an entire galaxy, a place where thousands of stars could fit within the space of a single light year. It's a humbling reminder of just how vast and dynamic our cosmic neighborhood truly is. And yet, for all its grandeur, the bulge remains one of the most mysterious regions in the Milky Way, hiding secrets about how galaxies like ours are born, live, and evolve over billions of years. But to truly grasp the wonder of the Galactic Bulge, we must turn our gaze to its ancient inhabitants. Here, time moves differently. Many of the stars shining in this dense core were already billions of years old when our sun first flickered to life. Picture these celestial elders glowing with a deep reddish hue, their light softened by age like embers in a cosmic fire. Unlike the youthful, fast-burning stars of the Milky Way's spiral arms, these ancient suns move with a slow, almost regal grace along their orbits. Their paths weave through the bulge like dancers in an endless ballet, each step shaped by the collective pull of countless neighbors. Some of these stars may have witnessed the very formation of the Milky Way itself, their light carrying stories from an era when galaxies were still taking shape. Imagine standing among them. The sky would shimmer with their warm, golden red glow, a stark contrast to the sharp blue-white stars we know from Earth's night sky. These aged suns hold clues to our galaxy's earliest chapters, their chemical fingerprints revealing how the first heavy elements spread through the cosmos. And as they continue their patient journey around the galactic center, they remind us that the bulge isn't just a place, it's a living museum of stellar history. Now, let's unravel one of the Milky Way's best-kept secrets, its hidden barred spiral structure. Picture a vast, glowing bar of stars stretching across the galactic center, like a cosmic highway guiding traffic toward the bulge. This central bar doesn't just sit still, it spins, slowly but powerfully, acting as a celestial conveyor belt. Stars and clouds of gas ride this gravitational current, drawn inward toward the dense heart of our galaxy. Imagine it as a grand, swirling dance, where the bar's rotation tugs on everything nearby, orchestrating their movement with invisible hands. Over millions of years, this motion funnels fresh material into the bulge, feeding its ancient stellar population and shaping its evolution. The bar's influence doesn't stop there. It even warps the orbits of stars farther out, sending them on long, looping journeys around the galactic center. This dynamic structure is why the Milky Way isn't just any spiral galaxy. It's a barred spiral, a subtle but crucial detail that makes our home in the cosmos unique. And as stars and gas stream along this barred pathway, they add to the bulge's ever-changing tapestry, a testament to the quiet, relentless forces that sculpt our galaxy. But now, let's turn our gaze to the true ruler of this cosmic kingdom, Sagittarius A star, the supermassive black hole lurking at the very heart of the Milky Way. Picture a monster so massive, it weighs 4 million times more than our sun, yet it sits there in eerie silence, like a slumbering giant. Its gravity is so overpowering that not even light can escape its grasp, creating a darkness so absolute it defies imagination. Right now, it's surprisingly calm, almost peaceful, as if taking a rare moment of rest. But don't let that fool you. This beast has a violent past. Centuries ago, it erupted in colossal flares, spewing energy across the galaxy with enough force to outshine every star around it. Those outbursts were like cosmic temper tantrums, reshaping the space around them. Today, we see only faint echoes of that fury, a quiet hum of radio waves, the occasional flicker of X-rays. Yet even in its stillness, Sagittarius A star holds the entire bulge in its grip, dictating the orbits of countless stars with its invisible pull. It's a reminder that sometimes the most powerful forces in the universe are the ones we can't even see. Now, imagine stepping into a place where the night sky isn't just sprinkled with stars, it's absolutely ablaze with them. This is the reality of the Galactic Bulge, where stars are packed so tightly together that standing on a planet, there would feel like being inside a glittering snow globe. Picture this: while Earth's neighborhood has just a handful of visible stars within a few dozen light years, the bulge crams hundreds of thousands into the same space. If you looked up, the sky wouldn't even have patches of darkness, just an endless sea of starlight, so bright it might cast shadows. Our own solar system feels almost lonely by comparison. Out here in the Milky Way suburbs, stars are spaced apart by light years, like distant neighbors waving across empty streets. But in the bulge, they're more like a bustling city crowd, shoulder to shoulder, their gravity constantly nudging and tugging at one another. Some stars orbit so close they could share atmospheres, while others brush past in chaotic near misses. It's a place where the concept of a dark night simply doesn't exist, just an eternal golden glow from countless suns, each adding its own whisper to the cosmic chorus. And yet, despite this stellar traffic jam, there's a strange harmony to it all. These stars have danced this way for billions of years, their paths woven into the fabric of the bulge itself. It's a reminder that the universe thrives in both solitude and crowds, and that even in the densest places, there's a kind of order, one we're only just beginning to understand. Now, let's take a closer look at the mesmerizing chaos unfolding in this crowded stellar neighborhood. The Galactic Bulge isn't just a dense collection of stars. It's a cosmic ballet where gravity plays the role of an unpredictable choreographer. Here, stars don't follow the orderly, circular orbits we see in the Milky Way's outer regions. Instead, they weave through space in wild, looping paths, tugged this way and that by the immense gravitational pull of their countless neighbors. Imagine a grand ballroom where dancers, each representing a star, move in every direction at once, their steps constantly shifting as they brush past one another. Some stars are flung outward in wide, arcing trajectories, while others spiral inward, drawn toward the heart of the bulge. These gravitational encounters can send stars hurtling at incredible speeds, their paths twisting and turning in ways that defy simple prediction. It's a dance without a pattern, where every movement is influenced by the invisible hands of nearby stars, gas clouds, and even the supermassive black hole lurking at the center. And yet, amid this apparent chaos, there's a strange kind of rhythm. Over billions of years, these stars have settled into a dynamic equilibrium, their collective gravity creating a delicate balance. While their individual paths may seem erratic, the bulge itself remains stable, a testament to the universe's ability to find order even in the most crowded and turbulent places. So as you drift into sleep, picture yourself floating among these celestial dancers, their hypnotic swirls and loops, lulling you deeper into the mysteries of the cosmos. But beneath this swirling stellar dance, the galactic bulge holds another secret one that shines in a light our eyes can't see. If we could peer through the veil with X-ray vision, the heart of our galaxy would blaze with an eerie glow, revealing energies far more intense than the gentle starlight we admire. This invisible radiance comes from some of the most extreme objects in the universe: neutron stars spinning at dizzying speeds, black holes silently devouring nearby gas, and white dwarfs locked in deadly gravitational embraces. Picture these cosmic powerhouses as whispers in the dark, their presence betrayed only by the high-energy X-rays they emit. When a neutron star's crushing gravity pulls material from a companion star, that stolen matter heats up to millions of degrees, screaming out in X-rays as it spirals inward. Elsewhere, solitary black holes too small to see directly reveal themselves when they rip apart passing clouds of gas, creating brief but brilliant flares. Even the quietest corners of the bulge flicker with these signals, like distant lighthouses blinking in a fog of dust and stars. What makes this X-ray symphony so fascinating is how much remains hidden. For every source we detect, there are likely dozens more obscured by the bulge's thick dust clouds. It's as if we're listening to a crowded room through a wall, catching fragments of conversation, but missing the full story. Yet each flicker and flare adds another clue, helping astronomers piece together the invisible architecture of this crowded realm. So as you drift deeper into sleep, imagine these ghostly signals pulsing around you, a hidden language of energy written across the galaxy's heart. Now, let's shift our gaze to a different kind of light, one that slips through the bulge's dusty curtains like a silent explorer. While X-rays reveal the violent dramas of neutron stars and black holes, infrared light tells a quieter but equally mesmerizing story. Imagine trying to look through a dense fog with only a flashlight. It's nearly impossible, but switch to a heat-sensitive camera and suddenly, hidden shapes emerge. That's exactly what infrared telescopes do for the galactic bulge. The dust clouds that block our visible light are no match for infrared's gentle persistence. These longer wavelengths glide around dust particles, revealing the warm glow of stars hidden behind the cosmic veil. It's like lifting a heavy curtain to find a room full of treasures, except here, the treasures are newborn stars, ancient red giants, and clusters huddled together in the darkness. Some of these stars are so faint in visible light that they'd be invisible without infrared's helping hand. And what do we find when we peer through this dust? A bustling stellar nursery where stars are born in thick cocoons of gas, and aging giants pulse with warmth as they near the end of their lives. Infrared eyes even spot the faint heat of planets forming around distant suns, worlds that might one day host life. Every glimpse deepens our understanding of the bulge's hidden layers, proving that sometimes the most profound discoveries come not from what shines brightest, but from what glows softly in the dark. So as you drift deeper into sleep, picture these hidden stars, their warmth seeping through the dust, their light waiting patiently to be seen. The bulge's secrets aren't just in the violent bursts of X-rays, but in the quiet, persistent glow of infrared whispers. Now, let's turn our attention to one of the most breathtaking sights, hidden within the galactic bulge, the delicate, glowing masterpieces known as planetary nebulae. These aren't planets at all, despite their name, but rather the final, radiant sighs of dying stars. Picture an aging star, much like our sun, but in its twilight years, gently shedding its outer layers into space. What remains is a luminous cloud of gas, glowing in vivid hues of blue, green, and red, like a cosmic stained glass window. Each planetary nebula is a unique work of art, sculpted by the star's final breaths. Some form intricate butterfly wings, while others stretch into delicate rings or spiral tendrils, as if the star itself is reaching out one last time. The colors come from the gases themselves: oxygen, glowing green, hydrogen, burning red, and nitrogen, adding hints of blue. It's a fleeting spectacle, visible for only a few tens of thousands of years before the nebula fades into the darkness, leaving behind a tiny, dense remnant called a white dwarf. What makes these nebulae even more special is their role in the galaxy's story. The elements they release, carbon, oxygen, and nitrogen, will eventually mix with interstellar gas, becoming the building blocks for new stars, planets, and perhaps even life. So when you gaze at these celestial jewels, you're not just seeing the end of a star's journey, but the seeds of future cosmic wonders. As you drift deeper into sleep, imagine these glowing nebulae scattered across the bulge, each one a silent testament to the beauty of transformation. Even in their final moments, stars leave behind something luminous, something lasting, a reminder that even endings can be dazzling. But now, let's shift our gaze to a quieter chapter in the bulge's story, the gradual fading of star formation. Unlike the spiral arms of our galaxy, where vast clouds of gas and dust collapse into brilliant new stars, the galactic bulge has settled into a more subdued rhythm. Here, the fiery birth of stars has slowed to a whisper, leaving behind a population of aging suns that have burned for billions of years. Imagine the bulge as a grand cosmic city, where the bustling construction sites of youth have given way to quieter streets, lined with older, wiser residents. The gas and dust that once fueled star birth have been either used up or scattered by the bulge's turbulent environment. Without these raw materials, new stars struggle to ignite, and the region becomes a gallery of ancient stellar giants, their light softer and redder with age. Meanwhile, out in the spiral arms, star formation thrives like a vibrant marketplace. Giant molecular clouds collapse under their own gravity, giving birth to dazzling clusters of young, blue-white stars. These stellar nurseries pulse with energy, their brilliance a stark contrast to the bulge's golden glow. It's a tale of two galactic neighborhoods, one still buzzing with creation, the other rich with history. Yet even in this quiet phase, the bulge holds its own kind of majesty. Its stars may no longer burst into life, but they carry the wisdom of ages, their slow dances telling stories of the galaxy's earliest days. As you drift deeper into sleep, picture this cosmic contrast. The fading embers of the bulge against the blazing fireworks of the spiral arms, each a beautiful chapter in the Milky Way's endless story. Now, let's turn our attention to the invisible threads that weave through our galaxy. The gentle but relentless pull of the bulge's gravity. Like an unseen hand guiding a grand cosmic dance, the galactic bulge exerts its influence far beyond its dense core, shaping the very fabric of the Milky Way. Picture this: stars on the outer edges of our galaxy, drifting peacefully through the darkness. Feel a subtle tug from the bulge's immense mass. It's not a violent yank, but a quiet, persistent force that nudges them into place, like a conductor ensuring every instrument stays in harmony. Over millions of years, this gravitational whisper bends their paths, sculpting the Milky Way into the majestic spiral we know today. Even our own sun, nestled in one of the galaxy's quieter suburbs, isn't immune to this cosmic influence. As it orbits the galactic center, the bulge's gravity tugs at it ever so slightly, a reminder that no star is truly isolated in this vast stellar tapestry. The farther out you go, the weaker the pull becomes, but it never fully disappears. It's a testament to the bulge's quiet dominance, a force that binds the galaxy together without fanfare or spectacle. And just as the moon's gravity stirs Earth's oceans into tides, the bulge's pull sends ripples through the Milky Way's structure. Entire star clusters and streams of gas respond to its command, their movements tracing the hidden contours of its influence. It's a slow, patient process, one that unfolds over eons, yet leaves its mark on every corner of our galactic home. So as you drift deeper into sleep, imagine the bulge as the steady heartbeat of the Milky Way, its gravity pulsing outward in silent waves, guiding stars near and far in an endless, graceful waltz. But now, let's shift our gaze to the silent guardians of the bulge, the globular clusters. These ancient stellar gatherings hover near the galactic center like cosmic elders, their tightly packed stars shimmering with the wisdom of ages. Each cluster is a relic of the universe's youth, a dense ball of hundreds of thousands of stars bound together by gravity's unbreakable embrace. Imagine standing on a world within one of these clusters, where the night sky would blaze with countless neighboring suns, so close together they outshine the darkness. Unlike the sparse scattering of stars in our own neighborhood, these celestial communities are bustling metropolises, their members orbiting in a slow, stately dance that has continued for nearly as long as time itself. Many of these clusters are older than the Milky Way's spiral arms, their stars forged in the early universe when heavy elements were scarce. Their reddish glow tells the story of aging suns, their fuel dwindling after billions of years of steady burning. Yet they endure, steadfast witnesses to the galaxy's evolution, their orbits tracing wide, graceful loops around the bulge. Some may have been born here, while others were captured by the Milky Way's gravity, drawn into its orbit like celestial wayfarers finding a home. Their presence adds yet another layer to the bulge's mystery, a reminder that our galaxy's history is written not just in stars and dust, but in these ancient, glittering families. So as you close your eyes, picture these globular clusters silent, majestic, and timeless, keeping watch over the bulge like sentinels of the cosmos, their light a whisper from the dawn of creation. Now, let's turn our attention to something far more elusive, the invisible embrace of dark matter surrounding the galactic bulge. Though we can't see it, touch it, or even detect it directly, its presence is undeniable, shaping the very fabric of our galaxy. Imagine a vast, ghostly halo stretching far beyond the bulge's glowing stars, its gravity silently guiding their motions like an unseen hand. Scientists first suspected dark matter's existence when they noticed something strange. Stars and gas at the edges of galaxies were moving faster than they should, as if some hidden force were holding them in place. Without dark matter's gravitational pull, these outer stars would simply fly away, scattered into the void. Here in the bulge, its influence is just as profound, subtly bending the paths of ancient stars and globular clusters, keeping them tethered to the galaxy's heart. What makes dark matter so mysterious is that it doesn't interact with light or ordinary matter in any way we can observe. It doesn't glow, reflect, or absorb. It simply is, an invisible scaffold upon which the visible universe is built. Some theories suggest it could be made of exotic particles, entirely different from anything we've ever detected, drifting through space in a silent, endless dance. Yet despite its secrecy, dark matter's fingerprints are everywhere. The way stars orbit the bulge, the way galaxies cluster together, even the way light bends around massive objects. All of these point to its unseen presence. It's as if the universe is whispering clues, urging us to unravel one of its greatest mysteries. So as you drift among the bulge's ancient stars, remember, there's far more here than meets the eye. An invisible ocean of dark matter cradles this cosmic hub, its gravity weaving the unseen threads that hold our galaxy together. And though we may never see it directly, Its embrace is the silent force that keeps the Milky Way whole. But now, let's shift our gaze to another astonishing feature of the Galactic Bulge, one that reveals its explosive past. Stretching high above and below the Milky Way's center, like two colossal hourglasses of energy, are the Fermi bubbles. These towering structures, each tens of thousands of light years tall, glow with gamma rays, the universe's most powerful form of light. They're remnants of a cataclysmic event, a cosmic eruption that likely occurred millions of years ago, though its exact cause remains one of the bulge's most tantalizing puzzles. Picture these bubbles as echoes of a long-forgotten outburst, their faint gamma-ray glow whispering secrets of the bulge's violent youth. Some scientists believe they were forged by a frenzied feeding spree of Sagittarius, a star, our galaxy's supermassive black hole, as it devoured enormous amounts of gas and dust. Others suggest they might be the aftermath of a burst of star formation so intense it sent shockwaves rippling through the galaxy. Whatever the trigger, these bubbles are proof that the bulge hasn't always been the quiet, ancient realm we see today. It once roared with unimaginable energy. What's truly remarkable is how these structures remained hidden for so long. It wasn't until 2010 that NASA, a Fermi gamma-ray space telescope, unveiled them, their faint emission lost in the background glow of the cosmos. Now they serve as a ghostly monument to the bulge's dynamic history, a reminder that even the most serene corners of space can harbor traces of past fury. As you imagine drifting through the bulge's starry expanse, consider this: those gamma-ray bubbles are still expanding, slowly fading with time. They're like ripples on a pond after a stone's toss, carrying the memory of a moment when the galaxy's heart trembled with power. And though their light is invisible to our eyes, their story is written across the sky, a testament to the fact that even in the deepest quiet of space, echoes of the past still resonate. Now, let's turn our attention to another mesmerizing phenomenon sculpted by the bulge's relentless gravity: stellar streams. Picture this as smaller galaxies, like cosmic wanderers, drift too close to the Milky Way's dense core. They don't pass through unscathed. The bulge's immense gravitational pull stretches and shreds these dwarf galaxies, tearing them apart over millions of years. What remains are delicate, shimmering trails of stars' stellar streams, floating like celestial ribbons through the darkness. These streams are more than just ghostly remnants. They're cosmic breadcrumbs, revealing the bulge's history as a devourer of galaxies. Each ribbon of stars tells a story of a smaller galaxy that ventured too close, its stars slowly siphoned away and woven into the Milky Way's tapestry. Some streams, like the Sagittarius stream, stretch hundreds of thousands of light years across the sky, their stars still moving in harmony, a final echo of their lost home. What's fascinating is how these streams help astronomers map the bulge's invisible gravity. Like detectives following a trail, scientists study the twists and bends in these stellar rivers to uncover hidden pockets of dark matter, the unseen force shaping their paths. It's a reminder that even in destruction, there's beauty and discovery. So as you gaze into the bulge's starry depths, remember, those faint, glowing threads are more than debris. They're the lingering whispers of galaxies that once were, now forever bound to the Milky Way's heart, a silent testament to the bulge's power to reshape the cosmos around it. Now, let's unravel one of the bulge's most puzzling contradictions. Its stars are both wealthy and impoverished at the same time. Imagine a treasure chest overflowing with gold, yet locked in a vault with no key. That's the metallicity mystery of the galactic bulge. The stars here are chemically rich, packed with heavy elements like iron and silicon, far more than our sun contains. These elements were forged in the hearts of earlier generations of stars, then scattered across the bulge by supernova explosions. You'd think such a metal-rich environment would be a bustling stellar nursery, brimming with gas to birth new stars. But here's the twist. The bulge is strangely starved of fresh gas. It's like a bakery with shelves full of flour, but no water to make dough. Why this paradox? One theory suggests the bulge's intense gravity and frequent supernova long ago blasted away or heated up most of its remaining gas, leaving little fuel for new star formation. Another idea points to the central bar funneling gas away, starving the core over time. Yet the truth remains elusive, a cosmic riddle written in the light of ancient stars. What's clear is that the bulge's stellar population is aging gracefully, like a city where the young have moved away, leaving behind elders with stories to tell. Each metal-rich star is a time capsule, holding clues to the bulge's fiery youth, a time when it was a crucible of creation, now quiet but far from empty. So as we ponder this celestial puzzle, remember, sometimes the universe's most profound secrets hide in plain sight, waiting for the right moment and the right observer to reveal them. Now, let's turn our attention to a cosmic detective tool that uncovers what even our most powerful telescopes cannot see: microlensing. Picture this. A distant star's light suddenly brightens for no apparent reason, then fades back to normal. This fleeting flicker isn't random. It's the universe whispering a secret. When an invisible object like a black hole or neutron star drifts in front of that star, its gravity bends and magnifies the starlight like a lens, creating a brief but telltale glow. These microlensing events are like cosmic winks, betraying the presence of hidden objects too dark or distant to observe directly. Imagine walking through a pitch-black room, guided only by the occasional brush of an unseen hand. That's how astronomers map the bulge's shadowy residence, by their gravitational touch. Each flicker reveals a compact object, perhaps a solitary black hole, left behind after a massive star's collapse, or a dense neutron star spinning silently in the dark. What's astonishing is how common these ghosts are. The bulge's crowded heart creates perfect conditions for microlensing, with stars and invisible objects constantly sliding past one another. Every flicker adds another piece to the puzzle, hinting at a hidden population of stellar remnants lurking in the darkness. Some estimates suggest there could be hundreds of millions of these compact objects woven through the bulge, far outnumbering the stars we see. Yet microlensing does more than just count invisible bodies. It helps us weigh them. The duration and shape of each light curve reveal the mass of the lensing object, offering clues about whether it's a black hole, neutron star, or even a rogue planet. It's like weighing a shadow by the way it bends the light around it. So as we peer into the bulge's depths, remember, sometimes the universe's most elusive truths aren't found in what shines, but in the subtle distortions of the light passing by. These silent watchers, hidden in plain sight, remind us that the cosmos still holds mysteries waiting to be unraveled, one fleeting glow at a time. Now, let's journey deeper into the heart of the galactic bulge, where the rules of gravity take on a whole new intensity. Here, in the central parsec, space itself seems to twist under the influence of an invisible giant, Sagittarius A star, the supermassive black hole anchoring our galaxy. Imagine a cosmic dance floor where stars don't just glide, they whip around at speeds so fast they'd cross Earth's orbit in mere days. These stars aren't just moving quickly, they are tracing wild, looping paths, their orbits stretched into eccentric ellipses by the black hole's crushing grip. Some swing so close that they're stripped of their outer layers, leaving behind glowing trails of superheated gas. Others, like the famous star S2, complete their orbits in just 15 years, reaching velocities of over 5,000 kilometers per second at their closest approach. To put that in perspective, that's nearly 2% the speed of light, a velocity where time itself begins to slow. What's even more astonishing is how these stars reveal the black hole's presence without us ever seeing it directly. By tracking their frenzied orbits over decades, astronomers have calculated Sagittarius A star's mass, a staggering 4 million times that of our Sun, packed into a space smaller than our solar system. It's like detecting an elephant by the way it bends the floorboards beneath it. Yet this inner sanctum isn't just about speed and chaos. It's also a laboratory for testing Einstein's theory of relativity. As stars like S2 swing near the black hole, their light stretches into longer, redder wavelengths, a gravitational redshift predicted over a century ago. Sometimes their paths even wobble slightly, as if space itself is rotating around the black hole, a phenomenon called frame dragging. So as we peer into this extreme realm, remember, the central parsec isn't just the Milky Way's most violent neighborhood. It's a place where the universe bends the rules, offering us front row seats to the strange and spectacular effects of gravity pushed to its limits. And with every star's wild orbit, we're reminded just how much there's left to discover in our galaxy's beating heart. But how did this swirling, star-packed heart of our galaxy come to be? Unraveling the origins of the galactic bulge is like sifting through cosmic sediment. Each layer tells a different story. Astronomers have two leading theories about its formation, and both paint wildly different pictures of our galaxy's fiery youth. The first theory suggests the bulge was born in a dramatic collapse, a rapid, violent event where vast clouds of gas and dust crumpled inward under their own gravity, igniting a frenzy of star formation in just a few 100 million years. Imagine a celestial fireworks display on an unimaginable scale, with stars bursting to life in dense clusters, their light flooding the young Milky Way. This rapid collapse scenario would explain why so many bulge stars are ancient, nearly as old as the universe itself, and why they orbit in chaotic, tilted paths, like debris scattered after an explosion. The second theory proposes a slower, more methodical buildup, a gradual assembly over billions of years as the Milky Way devoured smaller galaxies and absorbed their stars. Picture a cosmic sponge, soaking up stellar streams and dwarf galaxies, their stars gradually settling into the crowded core. This hierarchical growth idea aligns with the bulge's mix of stellar ages and chemical compositions, hinting at multiple generations of stars arriving in waves. Yet the truth might lie somewhere in between. Recent observations reveal the bulge isn't just one monolithic structure. It's a layered relic, with an inner region of older, metal-rich stars and an outer halo of younger, more diverse populations. It's as if we're peeling back the pages of a galactic history book, each chapter written in starlight. What's clear is that the bulge's formation shaped everything around it. Its gravity sculpted the Milky Way's spiral arms, and its stars carry chemical fingerprints of the galaxy's earliest days. So as we study these ancient suns, we're not just uncovering the past, we're piecing together the story of our cosmic home, one star at a time. Now let's consider a more dramatic twist in the bulge's story, one where our galaxy didn't just grow quietly, but feasted on its neighbors. Galactic cannibalism isn't science fiction. It's a real, violent process that shaped the Milky Way's heart. Picture a cosmic predator swallowing smaller galaxies whole, their stars torn apart and absorbed into the bulge's dense core. Evidence for this lies in the strange, looping paths of some bulge stars, orbits that don't match the rest. These stellar misfits are likely survivors of devoured dwarf galaxies, their motions still carrying the scars of ancient collisions. Chemical clues add to the tale. Some stars in the bulge have unusual mixes of elements, like cosmic fingerprints, pointing to foreign origins. But how does a galaxy consume another? Gravity does the heavy lifting. When a smaller galaxy drifts too close, the Milky Way's immense pull stretches it into shimmering streams, a process called tidal disruption. Over time, these streams dissolve, their stars joining the bulge's swirling dance. It's a slow feast, lasting billions of years, with each merger leaving behind a faint stellar trail. The bulge's hunger might not be over. Right now, the Milky Way is digesting the Sagittarius dwarf galaxy, its stars already splashed across our sky. And in the distant future, when the Milky Way collides with Andromeda, the bulge will grow even larger, a cosmic titan built on the remains of its neighbors. So the next time you gaze at the Milky Way's glowing center, remember, it's not just a collection of stars. It's a celestial graveyard, a monument to the galaxy's violent, insatiable past. Now, let's turn our attention to the stars themselves, the true inhabitants of the galactic bulge. This region isn't just a uniform crowd of suns. It's a cosmic melting pot, where stars of different origins and histories mingle like travelers from distant lands. Some were born here, in the bulge's ancient furnace, while others are immigrants, carried in by the galaxy's violent feasts. Take a closer look, and you'll spot two distinct families. First, the bulge's native stars, old, reddish giants that formed billions of years ago, when the Milky Way was young. These stars move in tight, orderly orbits, their chemistry rich in heavier elements forged in the galaxy's early fires. They are the original settlers, the backbone of the bulge's stellar population. Then there are the newcomers, stars with wilder orbits and unusual chemical signatures. These are the survivors of devoured dwarf galaxies, their paths still bearing the chaotic imprint of their violent arrival. Some even carry traces of elements rarely seen in the bulge, like cosmic souvenirs from their former homes. Together, these groups paint a picture of a dynamic, ever-changing neighborhood where stars from across the universe have come to stay. But the bulge's diversity doesn't stop there. Hidden among these stars are rare, fast-moving outliers, stellar rebels that defy the usual patterns. Some may have been flung here by close encounters with the supermassive black hole, while others could be visitors from the galactic disk, passing through on their own mysterious journeys. This mix of origins tells a deeper story. The bulge isn't just a relic of the past. It's a living archive where every star holds clues to the Milky Way's turbulent history. From ancient natives to interstellar wanderers, each one adds a thread to the galaxy's rich tapestry. So when you picture the bulge, imagine not just a dense swarm of stars, but a vibrant, ever-evolving community, a true cosmic crossroads. And as we peel back these layers, another mystery awaits: the striking contrast between the bulge's chaotic heart and the Milky Way's serene outer disk. But that's a tale for another moment. Now, let's step back and see how the galactic bulge fits into the bigger picture of our Milky Way. If the bulge is the galaxy's chaotic downtown, a place of crowded streets and constant motion, then the disk is its quiet suburb, where stars glide in calm, predictable orbits. This contrast isn't just about location. It's a tale of two entirely different ways of stellar life. Out in the disk, stars move like commuters on a well-planned highway. They follow neat, circular paths around the galaxy's center, their motions synchronized by the gentle pull of gravity. Here, star formation is still active, with glowing nurseries giving birth to new suns. The disk is orderly, youthful, and full of possibility, a place where stars have room to breathe. But venture into the bulge, and the rules change. Stars here don't follow tidy orbits. Instead, they dart and weave in all directions, like pedestrians in a crowded square. Gravity's grip is stronger, and close encounters are common. This is a realm of ancient suns, where star formation has slowed to a whisper. The bulge's stars are older, redder, and richer in heavy elements, relics of a time when the galaxy was fiercer and more turbulent. The difference even shows in their shapes. The disk is flat and thin, a sprawling spiral of stars and gas. The bulge, though, puffs outward, a dense sphere of stars packed tightly around the core. It's as if the Milky Way has two personalities, one calm and organized, the other wild and unpredictable. Yet these two regions aren't entirely separate. Stars from the disk sometimes wander into the bulge, just as bulge stars occasionally drift outward. Their interactions weave the galaxy together, creating a dynamic balance between chaos and order. So when you gaze at the Milky Way's glowing band across the night sky, remember, you're seeing not just a single structure, but a cosmic dance of contrasts, where the serene disk and the fiery bulge exist side by side. And as we ponder this divide, another layer of the mystery unfolds: the invisible force shaping them both. But that's a story for another moment. Now, let's cast our gaze far into the future, where the galactic bulge faces its most dramatic transformation yet. Billions of years from now, our Milky Way will collide with its colossal neighbor, the Andromeda Galaxy, a slow-motion cosmic dance that will reshape everything we see today. Picture this: as Andromeda draws nearer, its immense gravity begins to tug at the Milky Way's delicate structure. The orderly disk warps and bends, while the bulge, already a place of chaos, becomes the epicenter of an even greater storm. Stars that have orbited the galactic core for eons are suddenly flung into new, wild trajectories, like sparks from a firework. The bulge's dense heart, once a stable anchor, becomes a swirling maelstrom as the two galaxies merge. Yet amid this chaos, there's a strange beauty. The collision won't destroy stars outright. Instead, they'll weave through one another, their paths intertwining in an intricate celestial ballet. The bulge's ancient suns, along with Andromeda's own stellar population, will scatter across a newly formed galaxy, their light blending into a single, radiant core. Over time, the two bulges will merge, creating a vast, glowing center, a testament to the universe's relentless motion. And here's the most remarkable part. From within this future galaxy, any hypothetical observer would see a night sky ablaze with stars, far brighter than our own. The bulge's once distinct identity will fade, absorbed into something grander, a cosmic phoenix rising from the collision. But don't worry, this won't happen for billions of years. For now, the bulge remains a mysterious, bustling heart, holding its secrets close. And as we ponder its distant fate, another question lingers. What does our own night sky reveal about this enigmatic region? That's where our journey turns next. From our vantage point here on Earth, the galactic bulge reveals itself as a soft, golden glow, nestled within the constellation Sagittarius. Even with the naked eye, under dark, clear skies, you can spot this hazy patch of light, a whisper of the cosmic storm raging at our galaxy's heart. But what you're seeing is just a glimpse, filtered through thick curtains of interstellar dust that obscure nearly all of its brilliance. Imagine holding a flashlight behind a bed sheet. The light that bleeds through is faint, diffused. That's how the bulge appears to us, a dim echo of its true radiance. Yet for millennia, this mysterious glow has captivated stargazers. Ancient astronomers saw it as a celestial river or a gateway to the divine, while today's observers, armed with telescopes, recognize it as the core of our Milky Way, a place where stars crowd together like fireflies in a jar. Modern technology peels back the veil slightly. Infrared and radio telescopes pierce the dust, revealing hints of the bulge's chaotic splendor. But even now, much of it remains hidden, leaving us to wonder at the secrets it guards. On a quiet summer night, when Sagittarius climbs high in the sky, take a moment to gaze toward that faint glow. You're looking directly into the heart of our galaxy, across 26,000 light-years of space, a connection to the cosmos that humbles and enthralls, just as it has for generations. And if you could step outside our galaxy and see the bulge unobscured, its light would outshine 100 full moons, a dazzling beacon in the darkness. But for now, Earth's view offers its own magic, a reminder that the universe's grandest wonders are often veiled, waiting to be uncovered. Speaking of uncovering mysteries, let's shift our perspective again. What would the night sky look like if you stood on a planet deep within the bulge itself? The answer is as breathtaking as it is alien. Now, picture yourself standing on a world nestled deep within the galactic bulge. Here, the night sky would be nothing like the familiar darkness we know on Earth. Instead, imagine a celestial canvas so crowded with stars that true darkness is impossible. The heavens would blaze with countless suns, their combined light casting eerie, perpetual twilight across the landscape. The closest stars would loom large, some appearing as bright as our full moon, while others form dense clusters that resemble glowing clouds. With so many stellar neighbors, the sky would shimmer with a kaleidoscope of colors: red giants, blue supergiants, and ancient yellow stars all jostling for attention. Constellations as we know them wouldn't exist. Instead, the entire sky would ripple with an unbroken tapestry of light. And then there are the celestial fireworks. In such a densely packed region, stellar collisions and supernova would be far more frequent. Imagine witnessing a brilliant flash as two stars merge, or the sudden appearance of a new, dazzling point of light. A dying star's final, spectacular farewell. The Milky Way's core is also home to vast clouds of glowing gas, lit up by intense radiation, painting the heavens in hues of crimson and emerald. Yet, even with this cosmic spectacle overhead, the most awe-inspiring sight would be the galactic center itself. From within the bulge, the supermassive black hole, Sagittarius A, would dominate the sky, its invisible grip warping the paths of nearby stars into strange, looping arcs. The stars closest to it would streak across the heavens at impossible speeds, their frenzied orbits a silent testament to the black hole's overwhelming power. Life on such a world would be bathed in an eternal, starry glow, where night never truly falls and the sky itself feels alive. It's a view beyond imagination, one that reminds us just how diverse and wondrous the universe can be. And speaking of wonders, let's turn our attention to another enigma: how time itself bends and warps near the heart of our galaxy. Now, let's venture into one of the most mind-bending aspects of the Galactic Bulge: the way time itself twists and warps near Sagittarius A. Close to this supermassive black hole, the rules of time, as we know them, begin to unravel. Imagine standing on a spaceship, orbiting just beyond the point of no return, where the black hole's gravity is so intense that time slows to a crawl. For you, minutes might pass, but back on Earth, years could go by in the blink of an eye. This strange phenomenon, called time dilation, happens because gravity doesn't just bend space, it bends time too. The stronger the gravity, the slower time moves. Near Sagittarius A, the effect is extreme. If you could hover near its edge, your watch would tick far slower than a clock on a distant planet. To someone watching from afar, your movements would appear frozen, as if you were moving through thick syrup. Yet for you, everything would feel normal until you return to find the universe around you had aged without you. It's a cosmic paradox that challenges our everyday experience of time. Think of it like this: if you sent a signal to Earth from close to the black hole, each pulse might take years to arrive, even though, to you, they were sent just seconds apart. The universe itself would seem to speed up outside your bubble of warped time. This isn't just science fiction, it's a real prediction of Einstein's theory of relativity, proven in smaller ways here on Earth. Satellites in orbit, for example, experience time slightly faster than we do because they're farther from Earth's gravity. But near Sagittarius A, the effect is magnified to an almost unimaginable degree. So what would it mean to witness this firsthand? Picture a star spiraling toward the black hole. From our vantage point, it would appear to slow down, its light reddening and dimming as time stretches. But for the star itself, its final moments would pass in a flash. It's a haunting reminder of how much the universe still has to teach us, and how strange and wondrous its deepest secrets can be. And as we ponder these mysteries, let's turn our gaze outward to the vast structures that surround the bulge, shaping the galaxy itself. But even as we marvel at the strange dance of time near Sagittarius A star, the Galactic Bulge still holds onto many of its deepest secrets. Let's explore some of the biggest unanswered questions that keep astronomers awake at night. First, there's the puzzle of the bulge's true shape. Is it perfectly spherical, or does it have a more complex, boxy structure? Observations suggest a mix of both, but pinning down its exact form is like trying to map a cloud from the inside. The way stars move within it hints at a history full of collisions and mergers, leaving behind a shape that defies simple explanation. Then there's the mystery of the bulge's violent past. We've detected signs of enormous outbursts, colossal bursts of energy that must have shaken the entire galaxy. But what triggered these eruptions? Was it a sudden feast for the supermassive black hole, swallowing a passing star or gas cloud? Or could it have been something even more dramatic, like the collision of smaller black holes? The clues are there, buried in the faint echoes of radiation, still traveling through space. And what about the invisible hand, shaping it all, the dark matter? We know this mysterious substance surrounds the bulge, its gravity holding stars in place like an unseen scaffold. But how is it distributed? Does it clump together in hidden pockets, or is it spread smoothly like an ethereal fog? Without understanding this, we're missing a crucial piece of the galaxy's blueprint. These aren't just academic curiosities. Each unanswered question is a thread in the grand tapestry of our Milky Way story. Solving them could rewrite what we know about how galaxies live, grow, and change over billions of years. As we drift deeper into the heart of the galaxy, let's take a moment to imagine the view from within the bulge itself, a sky unlike anything we've ever seen. Now, let's close our eyes and drift into the heart of the galactic bulge, where time slows and the cosmos cradles us in its quiet embrace. Picture yourself floating effortlessly among stars older than Earth itself, their golden light bathing you in warmth. There's no up or down here, no rush, just the gentle sway of gravity guiding you past suns that have burned for billions of years. Each star tells a story. Some glow faintly, their energy waning like embers in a cosmic fire. Others pulse steadily, their light flickering as if whispering secrets of the galaxy's youth. The space between them hums with unseen energy, a reminder of the bulge's hidden forces at work. Around you, the sky is never dark. Countless stars crowd every direction, their combined glow painting the void in hues of amber and crimson. Distant nebulae shimmer like stained glass, their delicate tendrils curling around newborn stars or the last breaths of dying ones. It's a symphony of light and motion, slow and eternal. Feel the stillness here, the chaos of orbits, the pull of black holes, the whispers of dark matter. All of it fades into harmony. You're weightless, untethered, cradled by the same forces that shape the Milky Way. Let your thoughts dissolve into the vastness, carried away on the gentle currents of space. This is the galactic bulge as few will ever know it, not just a scientific wonder, but a place of profound peace. As the stars sway around you, let their ancient light lull you deeper into rest. The mysteries remain, yes, but here, now, they're not puzzles to solve. They're simply part of the quiet, endless dance of the universe. And with that, we gently return to our own corner of the galaxy, carrying the bulge's serenity with us. May its stars guide your dreams tonight and always. As our journey through the galactic bulge comes to an end, let's take one last moment to savor its quiet majesty. This ancient heart of our galaxy, where stars whisper secrets older than time itself, has cradled us in its golden glow. We've drifted past suns that outshine our brightest dreams, through nebulae painted with the colors of creation, and felt the gentle pull of forces beyond our understanding. The bulge isn't just a cluster of stars, it's a living story, a testament to the universe's endless creativity. Its mysteries linger like starlight on the edge of vision, inviting us to wonder without demanding answers. Tonight, let that wonder settle over you like a cosmic blanket. Carry the bulge's serenity into your dreams, where its distant light can guide you through the quiet hours. As you close your eyes, remember, you've touched the heart of the Milky Way. Let its slow, eternal dance lull you into rest, and may the peace of the stars stay with you long after this journey ends. Sleep well, traveler, beneath the watchful glow of the galaxy's oldest guardians. And if you've enjoyed this celestial voyage, don't forget to subscribe for more cosmic stories. Hit that notification bell so you never miss a journey through the stars. Sweet dreams, and see you among the constellations.